Right, this video is all made of instructor-created questions, so you're not going to see questions exactly like this in the textbook, but it's based off of what we were just doing in 9.7. And we are going to talk about interval notation today. So interval notation, we're going to use symbols that are, let me just show you the different types of symbols we can have. This is called an open interval. And it's something like a inequality that would be like this, where x is between a and b, but includes neither of them. Then we've got two types of intervals that are half open. And this one has the lower bound included. The upper bound is not included. Or I could have the upper bound included, but the lower bound not included. And finally, I can have what's called a closed interval. And both boundaries are included. Key idea here, note that infinity is an idea, not a number. So infinity can never be included. Also note any number not in the domain of the function cannot be included. So we're not going to include any numbers that make us divide by 0 or take square roots of negative numbers or anything like that in our solutions. Okay. So let's go ahead and let's get a little practice writing something from either an inequality or set builder notation, draw the correct graph, and then change that graph into interval notation. Hope you got that all written down because it's about to go away so we can do some problems. All right. Starting off with a problem that's written in set builder notation already for us. We're going to change the set builder notation into a number line graph where we're going less than 5 and not including it. So I'm going to have a lower boundary of negative infinity and an upper boundary of positive 5 that's not included. For this section, we're going to use parentheses for an open bound. And we're going to use brackets for in place of a closed circle. So where I was drawing open circles before, I'm going to put parentheses. Where I was putting closed circles before, I'm going to put brackets. They mean the same thing, but it's just another way to draw the interval that is easier to go straight to the interval notation. Right. Our next problem is x minus 7 is less than or equal to negative 5. We're going to add 7 to both sides, which makes this x less than or equal to 2. So I don't need to put set builder notation before I go to the number line. Here's 2. I'm going to put a bracket there. Like it to not try and complete shapes for me that I'm not trying to draw. And I'm going to shade to the left, like so. Okay. Now we have 11x minus 6 less than or equal to 10x minus 1. So we're going to bring all of our x's to the left. And all of our constants to the right. Using our addition property of inequality. And we get an inequality that x is less than or equal to 5. There's 5. I want less than or equal to. So this is going to be negative infinity to 5, closed off on the right. Next problem here is going to be 5x is less than negative 6.5. So we're going to divide both sides by 5. Because we're dividing by a positive number, we leave the inequality sign alone. This is going to be x less than negative 1.3. Strictly less than, there's no or equal to sign. So I get 1.3 wherever that is on the number line, and I need an open parenthesis, and I need to go less than that. So that's negative infinity to 1.3. Now we have x greater than 16 given to us. So 16 is there, and I'm going to draw it like so. And then I'm going to put that in interval notation. This one didn't ask me to draw the number line, but I'm going to do it anyways because it helps me get the right answer for my interval notation if I can see that. So lower bound of 16 not included, upper bound of positive infinity not included. And for our last problem here, this is going to be a graph that was given to us, and it has a lower bound of negative 9 that's open, and it has an upper bound here of positive infinity. So they've shaded all this on their number line. They want us to express that in interval notation. So lower bound negative 9, upper bound positive infinity. So there we go. That's it for this video. And I will see you back for the next video.